we're going to check out question number 9. We're going to find the cube roots of this complex number, -6 plus 6i, and we're going to do this one in degrees, just so I can show you that this formula works for both radians and degrees. So the first thing that we need to do is write this in trig form so that we can actually use that formula. So I'm going to go ahead and graph that. So we've got -6 and +6i. So that's what this looks like. So remember, trig form is r cosine theta plus I sine theta. So to find r, that's where we're going to use the Pythagorean theorem or the distance formula, whatever one you want to think of. So it's going to be the square root of 6 squared plus -6 squared. So I think it turns out to be the square root of 72. Yes. Okay. Now, we're going to leave it that way. It's better for later in the problem if we leave it in this and don't try and simplify it. And then for our angle, you can see that that's a 45-degree angle, so theta is going to be 135. Okay, so this is our z. Same thing as that, just written in trig form. And now we want to take the cube roots of it. So cube roots means we're going to have 3 solutions. So we'll start with z0, z1, and z2. Okay, so we're going to use this formula. We want to take the nth root of r. So what we're doing, I'm going to write this over here and then I'll put it over here. Nth root, we're taking the cube root, so we want the cube root of r, which is the square root of 72. Now, we're allowed to multiply those things. Can you see that? Let's make that bigger. Okay. Again, we're taking the cube root of the square root of 72 is what we're doing. Square root, remember, is index 2. So you're allowed to multiply these. This is the same thing as the 6th root of 72. So that's how I'm going to write that. The 6th root of 72. And then we have cosine of theta. Theta is 135. Now, this is where things change because we're doing degrees. We don't want to use 2 pi because that's in radians. So we just have to think of the equivalent in degrees, which is 360. So we're going to do 360 times k. K is 0. Over n. This time it's cube root, so n is 3. And then remember the sign's the same thing, so I'm just going to leave that blank. Okay, so this is going to give us the 6th root of 72. And 135, this is just 0, so 135 divided by 3 is 45. And then sine is the same thing. Ooh, we're good. Tight on space there. All right, for z1, we do the same thing. It's still the cube root of the square root of 72, so I'm still going to write that as the 6th root of 72. Cosine theta was 135. And then remember, instead of 2 pi, we're using 360 because we're in degrees. K, this time k is 1 over 3, and the sign is going to be exactly the same thing. So we have 135 plus 360, so 495 divided by 3. I think that turns out to 165. And sine is the same thing. And then for z2, same thing, cube root of the square root of 42, which is going to be the 6th root of 72. Oops, that's not a 7. Cosine theta is 135, and remember, instead of 2k, we're using 360. 2 pi, sorry, instead of 2 pi, we're using 360. And k on this one is 2. So we get the 6th root of 72, and we have 135 plus 720, and we're going to divide that whole thing by 3. I can't do that in my head, but I wrote down the answer, 285. our three answers in trig form, okay? Trig form of our answers. Now, if we want standard form as well, I'm going to do those in blue, I guess. These, we can't really do exact value because the 6th root of 72 is going to be kind of a mess. So what you're going to do is just put this into your calculator. You're going to do the 6th root of 72 times the cosine of 45. And when you do that, you get 1.44. And then you're going to do the 6th root of 72 times the sine of 45, which is going to be the same thing, 1.44i. Okay? On the next one, in your calculator, you're going to do the 6th root of 72 times cosine of 165. Make sure you're in degree mode. You should get negative 1.97. And then the 6th root of 72 times the sine of 165. I wrote that down, 0.53. All right, and then the last one, the 6th root of 72 times the cosine of 285, 0.53. And then the 6th root of 72 times the sine of 285 is negative 1.97i. Something that I didn't mention, which I should have, is these are always going to go in patterns. When you see your answers, particularly your angles, obviously this number out front is the same for all of them. You should see a pattern between those angles. That is always going to be the case. Okay? They should be evenly spaced. So these blue ones here are your answers in standard form. Now, we are also supposed to represent this graphically. I guess I'll squeeze that in down here at the bottom. So to represent these graphically, you're going to use standard form and you're going to graph these. So let me do my best here. So 1.44, 1.44 is going to be, I don't know, maybe about here. Negative 1.97 and 0.53 is about here. And 0.53, negative 1.97 is going to be here. And like I said, these are all going to be on a circle with a radius of r. Where's r? Radius of r. This number, sorry. Which I'm not exactly sure what that number is, but there it is. And then they are going to be evenly spaced. So I think that looks pretty good. Nice and evenly spaced around that circle. Okay. We will do one more of these. Hopefully you're catching on to the pattern and how this works.